Okay, so let's take a look at this section 5.3, sine law in acute triangles. So it's important to understand that if you have a triangle that does not have a 90-degree angle in it, you cannot use SOHCAHTOA and you cannot use the Pythagorean theorem. So if you take a look at this, it says sine law can be used for any triangle only if you have an angle and its corresponding side, you should say. Okay, so the sine law states in any acute triangle ABC, the ratios for each side for sine law is this. And you have either A over sine A equals B over sine B, C over sine C, or you could write it the other way around with the angles up top. Notice that the capital letters are the angles and the lowercase letters denote the side lengths. So also notice how to label a triangle. If this is triangle ABC, notice the capital letters are at the angles, the vertices. Little a is across from big A. Little b, side little b, is across from big B, and little c is across from big C. That's how you label the triangle. So let's take a look at this. It says, example 1, determine x to the nearest tenth of a centimeter. So let's pretend we don't see this solution here, but this is the triangle right here. Now, you have two angles, and you have a side that's opposite one of the angles. As soon as you have two angles and a side length, which is 9.2, okay, sorry. So as soon as you have two angles and a side length, then you could find out the other side length, okay, any other side length. Now, if it required us to find everything about the triangle, the first thing we would find is this angle here, because really when you're given two angles, you're given three angles, because all the angles add up to 180 degrees. Now, setting this triangle up, I'm going to label this triangle ABC, let's say. And they're giving us big A and big B. They're also giving us little b is 9.2. We have to find little a. So when you look at the two formulas, it is better to use the top one when you're looking for a side length because it's already prepared for you that way. All the side lengths are up top. It's better to use the bottom one when you're looking for an angle. All the angles are up top. So this question deals with big A and little a and big B and little b. Don't worry about the C's because it doesn't ask us anything about it. So I'm going to write this as A over sine A is equal to B over sine B. Remember, all of these ratios are equal. Ratios of the side length and its opposite angle. So little a I don't know, it's x. All over sine of big A I do know is 55 degrees. Is equal to little b, which is 9.2, all over sine of big B, which is 70. Now solving for x, quite simple. X is already at the top, so we're just going to cross multiply that sine 55. So I'm going to get x is equal to 9.2 times the sine of 55 all over the sine of 70. And if I continue this and round this to the nearest tenth of a centimeter, I'm going to get 8.0. And I know it's 8.01, but it's 8.0. We have to write 8.0, meaning that we have rounded this number to the nearest tenth, not just 8. If it was exactly 8, then we would write exactly 8. So that's how you do that one. Make sure you know how to plug this into your calculator and that your calculator is in degrees. So let's look at example 2. Example 2 says, determine all the interior angles in triangle PQR and round your answers to the nearest degree. So it just wants the angles in PQR. Now I'm going to erase all of this over here because that gives away the answer. But notice that what they give you triangle PQR runs like this. They give you that this side length is 112. They give you that this side length is 98. And they give you that this external angle, if this was a straight line, this external angle is 124. Okay? They give you that external angle is 124 there. So if you go to find all the angles, the first angle that you would try to find is clearly angle P, because you know that half of a circle is 180 degrees. Okay? So angle P is easily found. Angle P is going to be 180 minus that 124. And of course, angle P is going to be 180 minus 124 is 56 degrees. So this is 56 degrees. I'll write it over here. Okay? Because 56 plus 124 will give you 180 degrees. So then I can find, if I take a look at what I have here now, triangle PQR, I have this angle here, I have this side length, I have this side length. I can go and find this angle, because remember, the sine law always relates an angle in its opposite side length. So I'm going to rewrite this. I'm trying to look for big R, so I'll rewrite this as sine of big R all over little r is equal to sine of big P all over little p. Notice I didn't even bother with the q's because I do not know the opposite side length of q. So sine of big R, which I don't know, all over little r, which is 112, is equal to sine of big P, which is 56, all over little p, which is 98. Continuing this, I'm trying to solve for r, so I will cross multiply the 112. So this is sine of big R is equal to 112 sine of 56. And that's all over 98. And continuing this, I get sine of big R is equal to, I'm going to first figure out what this part is here, and this is going to be 112 sine of 56 divided by 98, and I get sine R is equal to 0.9474171,511. And of course, I can figure out R because R is going to be the sine inverse of that answer there. So R is going to be equal to, if I take the sine inverse of that answer, I get 70, and it's going to round to the nearest degree, I get 71 degrees. Okay? So I now have that P is 56, I have R is 71. I can clearly find Q because angle Q, notice that all of the angles always add up to 180. So angle Q is going to be 180 minus 71 minus 56. Just remember to make sure that your calculator is in degrees, and to also make sure that you know how to use your calculator if it's a number 1 or a number 2. And so when you subtract these, I get 53 degrees. So angle Q is 53 degrees. Okay? So that's it there. And so if I take a look at the second part of the lesson, says example 3 here. A wall that is 1.4 meters long has started to lean over, okay, and now makes an angle of 80 degrees with the ground. Now, I give you a picture of this. This is the wall starting to bend over. It's 1.4 meters tall, and it now makes 80 degrees with the ground. So you could have come up with this drawing already. A 2-meter board is jammed between the top of the wall and the ground to prop up the wall. So here's the 2-meter board, and it's jammed up against the top of the wall. Assume that the ground is level. So here's the ground. Okay. What angle to the nearest degree does the board make with the ground? So here's the board, here's the ground. What is this angle here? That's question A. So I'll figure out question A. So let's just label this. It doesn't matter what we label it. We can call it DEF, for instance. So triangle DEF. So according to this, I'm going to find angle F. I have this. I'm trying to find this angle. I have this side. I have this angle, and I have this side. So right now, this question only deals with big D and little d, and big F and little f. It has nothing to do with big E and little e. So I'm going to set this up to find big F. So sine of big F all over little f is equal to sine of big D all over little d. So sine of big F is theta all over little f, which is 1.4, is equal to sine of d, which is 80, all over little d, which is 2.0. So solving this, I just cross multiply the 1.4, so I get sine of theta, or sine of f, is equal to 1.4 sine of 80, all over 2.0. And continuing this, now I just have to plug in this into my calculator, so I get 1.4 sine of 80 equals divided by 2.0, and I get the answer of 0.68936547. And if I want theta, I'm going to take sine inverse of that answer. And it wants this to the nearest degree. So if I take the sine inverse of that answer, I get 44 degrees. It's actually 43.57, so 44. So this is 44 degrees. Let's look at question B. It says, what angle to the nearest degree does the board make with the wall? So now it's asking for this. What angle is that? I'll do question B down here because that one's very easy. We know that all the angles add up to 180 degrees. So obviously angle E is going to be equal to 180 minus 80 minus 44. And so angle E is going to be equal to, that is 100 minus 44 is 56 degrees. So 56 degrees is what goes up there. And question C, you could only imagine the only thing left is the distance here. So how far to the nearest tenth of a meter is the board from the base of the wall? So how far is D to F? Please don't go use the Pythagorean theorem because this is not a 90-degree triangle. I'm going to find little e, which is across from big E. So what do I use? I'm going to use big D and little d, and I'm going to use big E and find little e. I'm not going to use F. You can use F if you wanted to, but only use one of them. Obviously, you need to find little e, so you're going to have definitely this fraction, and you can have any of the other ones. It doesn't matter if you use D or F, but I will use D, so little d all over sine of big D. Okay? So if you continue this, this is going to be little e, which we don't know, all over sine of big E, which is 56, is equal to little d, which is 2.0, all over sine of big D, which is 80. Cross multiply this, I get E is equal to 2.0 sine of 56 degrees divided by sine of 80. So little e, it asks us to round to the nearest tenth. So I'm going to get 2.0 sine of 56 and then divide that by sine of 80. And I get 1.7 meters when I round to the nearest tenth. So make sure you know how to use your calculator, that it's in degrees, okay? And make sure you know how to plug these in. Know how to use a calculator number 1 and a calculator number 2.